Alright, today we are going to learn how we can easily add or subtract in standard form. Well, the technique we are going to be using is factorization technique. So we are going to look at for common factor amongst the number we want to add. So for the first example, you see we are adding, and if you watch closely, you discover that the common factor is 10 raised to the power minus 3. So we are going to factor it out. So we're going to factor 10 raised to the power minus 3. It's going to cancel 10 raised to the power minus 3, so we have 2.5 plus 1.5. So I have a teaching on factorization just in case you want to learn more on factorization. I'm going to put the link in the description. So now we just need to simplify the terms in the brackets. 2.5 plus 1.5 is 4. So our final answer is 4 times 10 raised to the power minus 3. And it's as simple as that. So this was very simple because the power of 10 was the same in both expressions. So it's 3 raised to the power minus 3 and 3 raised to the power minus 3. So but there are some cases where they are not the same, but for this one is the same, so it was relatively easy. So let's see the next example. We have 36. Now this is not 3.6. So if you have learned standard form, you discover that this is not even a standard form. So we're going to work on that later. So we have 36 times 10 raised to the power 5 minus 20 times 10 raised to the power 5. So again, lucky enough, we have the powers of 10 to be the same in both expressions because that's raised to the power 5 raised to the power 5. So we're just going to factor it out. So we have 10 raised to the power 5 and then 36 minus 20. 36 minus 20 is 16. So our final answer would be 16 times 10 raised to the power 5. Well, this is not our final answer because our solving is in standard form. We are asked to add in standard form, so we must leave our answer in standard form. So you recall that the general form of standard form, a times 10 raised to the power n, this a must be between 1 and 9. So we need to move the decimal point backwards. So the decimal point is here. I think I use another color. This is the decimal point now. So we need to move it just once towards the right, towards the left rather. So anytime I move the decimal towards the right or towards the left, the power of 10 is going to increase. So answer will now be 1.6 times 10 raised to the power 6 is going to increase from 5 to 6 because if you observe the place value system, you see that it increases from right to left. So this will be units, this will be tens, this will be 100, 1000 and so forth. So you see that as we go from right to left in this direction, the powers and the place values increase. That's why when we move our decimal point towards the left, the power of 10 will increase. When we move our decimal towards the right, the power of 10 would reduce, right? Because if you move backwards, you're going back and you're reducing the values from 1000, 100, tens, units, even on to tens, hundreds and all that. So that will be our final answer for this one. So let's see the next one. Now we have 7.23 times 10 raised to the power minus 4 minus 5.42 times 10 raised to the power minus 5. Now, we are not so lucky this time around because it's observed that the powers of 10 are not the same. So we can't factor out immediately. So all we can do, we are going to apply the laws of indices. However, bear in mind that there are many ways or rather multiple ways of doing this, but since we're using the factorization method in this video, we're going to say we're going to just choose one of the terms. All right, so I want to work with 10 to the power minus 5. You can also do the same for this. So I have 7.23 times 10 raised to the power, I think I'll just use another color to make everything clear, minus 5.42. Now you want to agree with me that 10 raised to the power minus 5, if you have done your indices, is the same thing as 10 raised to the power minus 4 times 10 raised to the power minus 1. Because when the bases are the same, remember you add the powers, and if you recall, minus 1 plus, or rather minus 1 minus 4 plus minus 1 plus minus is minus. We have minus 4 minus 1, which is also equal to minus 5. So 10 raised to the power minus 4 times 10 raised to the power minus 1 is the same thing as 10 raised to the power minus 5. We just splitted it. And why are we doing this? We're doing this so that we can have a common term. Now you see that we have 10 raised to the power minus 4, 10 raised to the power minus 4, so we can factor that out. So let's do that. Now factoring it out, we have 10 raised to the power minus 4 into 7.23 minus, now we have on this side we have 5.42 times 10 raised to the power minus 1. So we're going to move the decimal back, right? So this is going to give us ultimately 10 raised to the power minus 4 into 7.23 minus, if we move the decimal back, power is going to increase. So it's going to increase by 1. I know minus 1 plus 1 is 0. And then 10 raised to the power 0. 10 raised to the power 0 is equal to 1. So we just have a number there. So when I do this, it's going to be 0.542. That's what we have there now. So let's subtract 7.23 minus 0.542. Subtract, we have 6.688 times 10 raised to the power minus 4. And this is our final answer. So anytime the powers of 10 are not the same, you just have to apply the laws of indices. Or now another thing you can want to do is that instead of breaking this down like we did in this point, you can go directly. You can go directly by, remember, anytime move the decimal towards the right, the power of 10 will decrease, and anytime move the decimal towards the left, the power of 10 will increase. Now what we need here, do we need the power to decrease or increase? If the power decreases, you see that it's going to go from -5 to -6, and that's not what we want. We want it to get to -4, so we need to move towards the left so that the power of 10 will increase. -5 plus 1 will be -4, and then we can solve quickly. So that's why I said there are multiple ways of doing this. So, but I think anyone should go. So in the next example, we're going to try and use this method. Let's see the next example. So we have 3.72 times 10 raised to the power 4 plus 2.34 times 10 raised to the power 5. This time I say again, the powers of 10 are not the same. This is raised to the power 4 here, this is raised to the power 5 here. So we have many options. We can decide to increase the power from 4 to 5 in this part, in this first part, or we can decide to reduce the power in this second one. So whichever one we want, we're going to work with it. So let's work with the first one. Let's increase 10 raised to the power 4 to 10 raised to the power 5. To do that, you discover that we have to move the decimal towards the left so that the power increase. So we now have 0.372 times 10 raised to the power 5 plus 2.34 times 10 raised to the power 5. Having 10 raised to the power 5 common now, we can factor it out. 10 raised to the power 5 into 0.372 plus 2.34. Now let's just add what we have together. Adding it now, we have 2.712 times 10 raised to the power 5, and this is the answer. So it's always important to always check your answer carefully. So always make sure that the value you're getting, as a multiplying with 10 raised to the power any power, must satisfy our need for a. Remember, a must be a number that is between 1 and 9. So 2.712 is between 1 and 9, so it satisfies that requirement. So sometimes you might solve and get an answer like 25 times 10 raised to the power 6, for instance. So if you're asked to solve in standard form, you need to reduce this 25 to make sure it's a number between 1 and 9. I have to move decimal towards the left, so it's going to be 2.5 times 10 raised to the power 7, because you moved the decimal towards the left. And what if you have a final answer like this? Let's say 0.54 times 10 raised to the power 2. All you have to do, you need to move the decimal this time around forward 1, so the power of 10 is going to reduce. So your final answer in this case will be 5.4 times 10 raised to the power 1. And that's it. And of course, you need to know that if you're given a unit number, let's say 5 or 4, and we ask to write 5 in standard form, we just need to multiply by 10 raised to the power 0. Alright, because 10 raised to the power 0 is 1. 1 times 5 is still 5. So that is it for addition and subtraction in standard form. Thank you for joining, and God bless you.